So you've taken a look at how to graph linear functions as kind of a repeat to what you did last year. Today we're going to look a little bit at something a little bit new, and that is graphing linear inequalities. So what happens when we don't have an equal sign, but we have a less than or greater than symbol in there? So what we're going to do, and the first step that we need to do, and this is the only thing, and there's really nothing different than linear functions except kind of what it looks like. But we put the inequality into what we call graphic form again. So that's y is equal to mx plus b, or less than mx plus b, or greater than mx plus b. We plot the b on the y-axis just like we did with graphic form. That's our y-intercept. We move our slope to one of the point get our second point. So again, rise over run. We connect our 2 points and we label everything. Now the only difference is that we shade above or below the border that we got using the equation. Okay, so the equation is the line, that's our border. We now shade either above or below it to represent our inequality. And I'll display this a little bit once we get through our first one right there. So our first graph right here, and I'm just going to quickly label again. I should maybe do this on my master copy so I don't always have to go through, but you never know if you need to go up by 2s or 4s or something else. And even though normally it is just 1s. All right, so we want to graph y is greater than 2x minus 4. So we start with making that borderline, and the borderline is represented by the linear equation, which is exactly the same except has an equal sign. And so the negative 4 is our y-intercept right there, and then the 2 is our slope. Okay, so remember, this is m, this is b. Now 2m is equal to 2 over 1. So we remember it as a fraction. It is rise of 2, run of 1. So we go up 2, run of 1. It just means it's going to be a little bit of a steeper line than if we had a fraction less than 1. And I'm going to try to draw this again as accurate as possible. And there's the line. Now, I'm going to get to where the error in this is in just a little bit. But that would be the line that we draw. Now, the thing to watch out for is that, in fact, this line is not a part of our solution. Okay, it's not equal to, and so the line is not actually part of our solution. It's just the borderline. So instead of drawing it in bold like that, we're going to actually draw it dashed. So the red is going to actually represent our line, and I'm going to draw it as dashed. Okay, so it is a dashed line, as the line is not part of our solution. That's what this says right here. Okay, so if we don't have the equal sign in there, if it's just less than or just greater than, then the border will be dashed as it's not a part of our solution. Okay, it's not a part of the solution. A point on there would not actually work in this inequality, and we'll go through that in just a little bit. Okay, now we want to shade one or the other side to represent which one works. Okay, and once we have it like this, when it says greater than, it usually means it's a top side. If it's less than, it usually means it's a bottom side. How we can check is by using what we call a test point. And sorry, we need to label these points here really quickly. This was 0, negative 4. This was the point 1, negative 2. Okay, and this is y. I'm going to do that in just a little bit yet. Okay, well, I'll put the inequality in which side is shaded. So we want to use a little test point. I'm going to use the point 0, 0. That's my little test point there. And I'm going to put 0 into the inequality. Okay, to see does it actually work or does it not work. When we solve it, it's 2 times 0 is 0, minus 4 is negative 4. 0 is, in fact, greater than negative 4, so that one works. That means that this side is where we shade. And so I'm going to put my inequality in there, and then I'm going to shade this region right here, meaning, okay, and with this inequality, meaning that every point in this region works with this inequality, and no point in this region works with the inequality. Now we also know that because this line is dashed, okay, those points on the line do not work with the inequality either. I'm just going to quickly go through a couple of points like that. I'm going to use this point right here, which is at 2, 0. I'm going to use that point right there. 2, 0 is on the line. Okay, and we say the line is dashed, so that means that it's not a part of it. And let's just see the point 2, 0. Put that right there. So we're going to have 0 is greater than 2 times 2 minus 4. 2 times 2 is 4, minus 4 means that 0 is greater than 0. Now you might understand, and hopefully understand, that this is in fact an untrue statement because 0 is not greater than 0, it is equal to. So that means that this point does not work with this inequality. It does not work with the situation that we're trying to do, and so it's not a part of the solution. 0, 0 in fact was, and I'm just going to label that right here. 0, 0 was part of the solution, okay, because it worked. The 0, 0 does not work, and if we chose any point from this side here, we would understand that it doesn't work. Now you may be asked to find a solution or 2 solutions or however many solutions to this inequality. It will be any point on this side of the graph right here. Anything in this shaded region, could even be farther up, as we do put our arrows to make sure we understand that it is in fact keeping on going forever and ever because there is no context to this one.